In our next lesson, we're going to be talking about the greatest common factor. In our terms, the first term is going to be a common factor. It is a whole number that is a factor of two or more non-zero whole numbers. Our next term is called the greatest common factor. And that is the greatest of the common factors, and that's called the greatest common factor. So in our first example, we're going to look at a word problem. We're talking about a music choir. A choir director wants to divide a choir into smaller groups. The choir has 24 sopranos, 60 altos, 36 tenors. Each group will have the same number of each type of voice. What is the greatest number of groups that can be formed? And then how many sopranos, altos, and tenors will be in each group? I'm going to teach you two methods in order to solve a problem like this. Our first method is we're going to list the factors. I'd like to ask you to list the factors for 24, 60, and 36. I'm going to pause the video. We're going to come back and check your work. Now we've listed the factors for those three numbers. We need to determine how many groups that these three numbers can be divided into. So we're going to look at the greatest common factor. And you'll notice they have common factors, but the greatest common factor for those three numbers is 12. That's the first method. The second method is what we're going to focus on. Method 2 says to write the prime factorization of each number. And then to find the greatest common factor, it is the product of the common prime numbers, what they have in common. So I'm going to pause the video again. You're going to determine what the prime factorization is for 24, 60, and 36. Now, after I did the prime factorization and put my totals, again, you may use either method, the upside down L or the factor tree. I went back and checked to make sure that they were correct. Now, we're going to determine what the greatest common factor is of 24, 60, and 36 in order to determine how many groups that these need to be divided into equally, or what's the greatest factor of those three numbers. So it has to be a common factor. It has to be in each one of those numbers. So since they're in order, from least to greatest, I'm going to look at my twos. Note how I set the problem up. I did the prime factorization for 24, 60, 36, GCF at the bottom of that list. They each have at least two twos in common. Then I'm going to check my threes. They each have at least one 3 in common, and that's all that they have in common. So 2 squared times 3 is 12. So the greatest common factor of those two numbers, of those three numbers is 12. So the greatest number of groups that can be formed is 12. Now that was the first part of our question. The next one is, how many sopranos and altos and tenors are there going to be? So notice we had 24 sopranos. So 24 divided by 12 groups, there's going to be 2 in each group, so 2 sopranos in each group. We had 60 altos. We divide the 60 into 12 groups. We have 5 altos in each group. And lastly, we had 36 tenors. And if we divide the 36 tenors into 12 groups, we are going to have 3, which means there are 3 tenors in each group. So if you have a problem like this, you first of all do your prime factorization. Your totals, you need to list it just like this in order to be very organized with your work. Once you find out how many groups they're going to be into, then you can decide how many are in each group from that. Now, we're going to check our work to see if we understand the concept. So, we're going to numbers 1 and 2. I'm going to ask you to find the greatest common factor of the numbers. I'm going to pause it. We're going to come back and check your work. Okay, you'll notice, again, I did the prime factorization for 28, 42. I checked to make sure that they were correct. Then the GCF, the greatest common factor, was 2 times 7 is equal to 14. GCF of those two numbers is 14. I did the same in number 2. I did a factor tree for each one, checked my totals to make sure that they were correct, found the greatest common factors, multiplied them, greatest common factor of those two numbers is 120. Okay, we have one more example. Let you work this out. Pause the video and we'll come back and check that. Okay, again, we did our factor trees, found the prime factorization for each one, checked our work, noticing that the greatest common factor was 3 squared. 3 squared is 9. Now, our next term that we'll be using is called relatively prime. Two or more numbers are relatively prime if their greatest common factor is 1. I have an example for you right here with numbers 77 and 51. I'm going to ask for you right now to do a prime factorization of those two numbers. Set it up just as we had in the previous example to determine what their greatest common factor is. I'm going to pause the video. We'll come right back. So you'll notice on this example when we did the prime factorization of 77 and 51, the only factor that they have in common is 1. So on our next screen, we're going to check our work. This is the type of problem that you'll be seeing. Find the greatest common factor of the numbers, then tell whether the numbers are relatively prime. So you're going to do your prime factorization, find the greatest common factor. Your final step would be to say relatively prime or not relatively prime. I'm going to pause the video, let you do that work, and we'll come back and check our answers. So on these two examples, we first did the prime factorization. We checked our totals. We noticed on the first example that their greatest common factor was 11. So we also noted that they're not relatively prime. In number 5, did the prime factorization, same thing. We noticed that the only common factor that they had, the greatest common factor, was 1. So those two numbers are called relatively prime. Some examples, you might have 3 numbers that you have to compare. Again, if it asks you to state whether they're relatively prime or not, that is part of the answer. In our next example, we're going to be finding the GCF of monomials. You've been asked to find the greatest common factor of 18xy squared and 28x squared y squared. In order to determine what the greatest common factor is, you're going to again do the prime factorization of 18 and the prime factorization of 28. Let's do that first and we'll come back and finish up the problem. So you notice I took the prime factorization of 18xy squared. That would be 2 times 3 squared times x times y squared. 28x squared y squared is going to be 2 squared times 7 times x squared times y squared. Again, as we did before, we're trying to find the greatest common factor. So we're going to notice in this example 2 times 7, what would be our next common factor? We'll look at the x's. Do they, not 3, not 7, but the next common factor will be they each have at least 1x. Then we're going to compare our y's. They each have at least 2 y's. So the greatest common factor of this example will be 2xy squared. Okay, we're going to move to the next screen. We're going to check our work to make sure we understand it by referring to the previous example in order to do 6 and 7. I'm going to pause the video, come back and check our answers. Okay, again, notice our totals for our prime factorization and the greatest common factor for each one. Greatest common factor will include the variables with monomials.